Welcome to an extraordinary and behind-the-scenes look at one of the most crucial steps in setting up our state-of-the-art MRI. And today we embark on a fascinating journey of constructing a Faraday cage. This essential structure will ensure that our MRI operates without interference, providing the highest quality imaging. Now watch the magic happen behind me as the team transforms these raw materials into a sophisticated Faraday cage. And this process is crucial to create an electromagnetic shield that will protect our MRI machine from external radio frequency interference. Step by step and day by day, we are building our success, remembering what Walt Disney said. The way to get started is to quit talking and begin doing. Welcome to the heart of our new MRI facility, the Faraday cage. As you can see, the interior is lined with copper to create a conductive barrier against external electric fields. But what exactly is a Faraday cage? And why is it essential for an MRI? To demonstrate how a Faraday cage works, let's conduct a small experiment using a radio, a metal pot, and aluminium foil. Turn on the radio and carefully place the radio inside the metal pot. Cover the pot with aluminium foil. In most cases, the radio signal should be significantly weakened or completely blocked, demonstrating the effectiveness of the Faraday cage in shielding the radio from external radio frequencies. This simple demonstration shows how a Faraday cage can protect sensitive equipment like the radio frequency receivers in the MRI from interference caused by external electromagnetic fields. A Faraday cage is designed to block electromagnetic fields, ensuring that our MRI operates in a controlled environment, free from outside interference. This is crucial for achieving precise and reliable imaging. The magnet will be positioned here, shielded from external radio frequencies that could disrupt its operation. Are you excited to see the next steps? If yes, don't forget to subscribe to my channel to stay updated on this incredible journey.